The first video for this week, or the second video, is focused on weighted effects coding. So the example I'm going to use is the same example I ran through last week, where I have happy as my dependent variable, pet and mess as my two predictors, and they're both categorical. And what I have here is a table, a summary of my unweighted effects. So you can see here, these are the coefficients that I've been talking about as before. And these coefficients are B's, and these B's represent unweighted effects codes, as we've discussed previously. Now, one of the things that's central to distinguishing between unweighted and weighted effects codes is the idea of equal cell sizes. So this is a big deal in ANOVA, because unequal cell sizes oftentimes leads to differences in variance that are attributable largely to just cell size differences. But in this case, what we need to do is we need to counter the potential effects for unequal cell sizes by changing the effects codes to reflect the ratio of or the differences in cell means, or not cell means, sorry, cell frequencies. So take a look at this table here, and you'll see that this is mess, the codes no mess versus mess, and then cat, dog, fish, and pig, and you'll see that these are cell counts, that in total there were 20 cats, 10 dogs, 30 fish, and 40 pigs, and you'll also notice that all of the cells are of different magnitude. Now, for just for simplicity's sake, what I intend to do is to cover the main effects, because that tends to be just the easiest. And what I want to show you is the contrasts here. The contrasts assume equal cell sizes, so you can see 1 versus -1 for each one of these. So my effects code for cat is 1 to -1, and for dog is 1 to -1. These are all comparing to pig. But what I want to do is I want to change not my ones, but I want to change the pig effect so that it reflects the proportion of pig to whatever contrast we have. So here I've got, excuse me, I have cat compared to pig, and instead of having a -1, instead what I want to do is I want to change my coefficient to weight it based upon how many pigs there are relative to cats, or really cats to pigs. So this is the way I'm going to change it, is that instead of having a -1, I'm going to have the frequency of cats relative to the frequency of pigs reflected. So how many cats do we have? We had in total 20 cats. And how many pigs do we have? We have 40. So instead of having a -1, instead I'd rather have 0.5. And so this is a weighted effects coding where the weights reflect the changes in frequencies for each of the effects. So here I've got -0.5, because pig, remember, is our comparison, so that's always going to be minus. But you'll notice here that I have a 0.5 here, because there are far more pigs than there are of cats. Here's dog, and as I said before, the frequency of dog is 10, 4 and 6, and the frequency of pigs is 40, so that should be, for every dog there are 4 pigs, so that would be 0.25. And then it's 0.75 because there were 30 fish, and you'll see here 17 and 13 is 30, and there are 40 pigs, so there are 3/4, and that's reflected in 0.75. So when I run this, now I change the contrasts, and I get different results. Now what I want to show you is These are the results that I get from just the standard model that I ran before. And what I want to show you is, or sorry, these are, I've collapsed all of the unweighted, that's the first column, and the weighted to show you that the effects do change. They change because the cell frequencies change. So remember, we no longer have 1 to -1. What we have is we have 1 to minus a ratio of the focal group to the comparison group for cell size magnitude. And this turns out to be a slight change. As you notice that all of the effects change slightly. They don't change a tremendous amount, but we want to be able to work backwards and get the marginal means. And that's what we're going to do in the next step. So stay tuned for that.